problems. Here we have three graphs showing three different transformations of our pre-image graph, which is the dashed line. And we want to determine what transformations were done verbally and then write an equation for g of x in terms of the function f, our original graph. Let's start with the one here on the left. Now, the way I like to approach these graphs is to find corresponding points in both the pre-image and the after image. So, on graph f, I can see that I have the point -3, 1. Then I have the point 1, 3. And then I finally have the point 4, -2. These are my three original identifiable points on the pre-image. Now I look at G, and I see what those corresponding values are for each of those points. Now the first point is -3, 3. The second point is 1, 9. Finally, the third point is 4, -6. Now I look and see what consistent operations allow me to come up with the new values in G. As we can see, the x values haven't changed. -3, -3, 1, 1, and 4, 4. But the x values go from 1 to 3, 3 to 9, and -2 to -6. To make these new values, we can see that the consistent operation is multiplying by 3. So we multiply all our y values by 3. We have dilated our graph vertically by a factor of 3, which would mean that our new function would be g of x 3 times the original function. Let's double check that. The vertical dilation by a factor of 3 verbally at g of x is 3 as f of x. Great. Now let's look at our second function. Again, we had -3, 1, 1, 3, and 4, -2. Our new values are -3, 7, and 1, 9, and 4, 4. So here, again, our x values are all the same. But each of our y values has changed by a constant value of 6. So we added 6 to each of our y values. So we would say we saw a vertical translation or shift of +6 units. G of x equals f of x +6. Check here. Vertical translation by 6 units. G of x 6 plus f of x. Or f of x plus 6. Great. Okay. Let's try again. Final function transformation. Here, again, we have those three values. 3, 1, 1, 3, and 4, -2. Our new values negative 6, and negative 6. Next value is 1, 2, and 3 to negative 4. Final goes from 4 all the way up to 8, negative 2, and negative 9. So here, both our x and y values change. We see that we go from 3 to negative 6, 1 to 2, and 4 to 8, which are all multiplied by 2. They're not wider by a factor of 2. On the other hand, we see that our y values go from 1 to negative 6, 3 to negative 4, negative 2, negative 9. Here, each of our y values have dropped by 7 units. So now we need to figure out how to write the equation that would reflect both of these operations. Because our graph got wider horizontally, we have to remember that it's counterintuitive. So since it got twice as wide, we have to multiply our f of x by 1/2. Vertically, we dropped 7 units. So vertically, things make sense. So our g of x should be f of 1/2 x minus 7. Pull that out. See a horizontal dilation by a factor of 2, we've got twice as wide. And a vertical translation by negative 7, it dropped 7 units. And you can see that our equation matches g of x equals negative 7